Hello folks, let's come to this part 1 video of this exercise 5.5, and we are coming to a totally new concept, that of logarithmic differentiation, and it's a very important tool in this differentiation chapter when we are taking the derivatives. Very important and very instrumental in finding complicated functions. So before we go to the logarithmic differentiation, I will just like to tell you some of the properties of logarithms. That suppose say when you take the logarithm is a full word, and we when we represent it as a function we call log. Suppose say there is a log of a raised to m. The log gives it a property that it will become m log a. That means suppose if you have log of 2 raised to 5, it will become 5 log 2. That property is very instrumental. We keep using it here and there in this problem. Also, suppose if you have log of a by b, then that can be written as log a minus log b. Similarly, suppose if you have log ab, then it can be written as log a into log b. That is, suppose if you have log 2 into 5, then this is log 2 plus log 5. So that's some of the properties that we'll be using there, and that's how we'll be getting across doing the problems. So this is more or less the properties that we have to use in the upcoming problems. So problems are very complicated. If they're like, for example, this problem, first one, where had it been product of two functions, we would have used the product rule and we could have done it. Now this is three functions product. And see the next question, where you have the root of already a fraction, and fraction itself, the numerator and denominator are quite complicated, made up of so many terms. So such kind of complicated expressions, generally we go in for a logarithmic differentiation, and that's how you get the problem solved. Now what is the meaning of logarithmic differentiation is, to the given question, first you take log on both sides, and then you go in for a differentiation. That is the meaning of logarithmic differentiation, because log has got, as I told you, many properties. So because of these properties, the problem becomes simpler, and then it is better to get the derivative rather than going it directly. It's not that you cannot do it directly, but it's very complicated. So let's start right away by calling this as y. Let y be this particular thing, and as we are planning to take the logarithm on both sides, so it is going to be log y here, and it's going to be log cos x plus cos 2x, log cos x into cos 2x into cos 3x, because we have taken log on both sides. So log y, and now here we are using the log property. Log property says that if you have log of a product, then you can just add up these things with the log. So this will now become log cos x plus log cos 2x plus log cos 3x. Now keeping it like this is of no use to us, because we have to get dy by dx. So we are taking the derivatives on both sides. So we have to get derivative with respect to x on both sides for log y, and derivative with respect to x on both sides for all these terms, log cos x plus log. First problem I'll write elaborately. Now next problem onwards we will skip some steps. Okay, this is log cos 3x. So automatically the derivative distributes d by dx log cos x, then d by dx of log sin a, log cos 2x, then d by dx of log cos 3x. Now to find this, what we will do is one of the functions, 3x or 2x, something we will take, and we will understand how the derivative is, and then we can apply it directly. Maybe we will call this as 1. And consider a u to be log cos 3x. We are planning to find the derivative du by dx, but let's see how we can do it. And this is quite complicated. Cos is there, log is there, cos is there, 3x is there. So many things are there. So what we will do is, for our simplicity, we will call cos 3x, I think we can manage, v as cos 3x. So u will become log v. So we can find the derivative of v with respect to x. It is minus 3 sin 3x. We have learnt. And u is in terms of v, so you can find out derivative of u with respect to v. It is 1 by v. So du by dv and dv by dx we have found out. We know that we should be getting du by dx. So du by dx by formula is going to be du by dv into dv by dx when we apply the chain rule. And du by dv, it's there with us, it's 1 by v. And dv by dx is there with us, it is minus 3 sin x. Sin 3x, sorry. So this is minus 3 sin 3x by v for us is what? It's cos 3x. So this modifies to minus 3 tan 3x. So we will write similarly, and you will have derivative of log cos 2x will be minus 2 tan 2x, and derivative of log cos x will be minus tan x. Right. Then we'll revert back to 1, and from 1 we will find out what it is. From 1, derivative of log y with respect to x. Derivative of log y with respect to y is 1 by y, we know. And because this is with respect to x, we will write dy by dx. Right. And all these derivatives we have found out here. For log cos x, it is minus tan x. For log cos 2x, it's minus 2 tan 2x. And for this, it is minus 3 tan 3x. So finally, you will get dy by dx as minus y times. This can go there. All minuses you can take out. Tan x, tan 2x, tan 3x. Again, y is your creation. So let's have it. Minus cos x, cos 2x, cos 3x times tan x plus tan 2x plus tan 3x. That's your answer. Right. So that's where you can get to know the advantage of a logarithmic differentiation, that whenever the logarithmic differentiation comes, when we apply the log, things becomes much more manageable. If you could think of some other method, we'll be wasting so much of time in doing it, because when we could have taken product rule twice and done it, but that will become really laborious. So compared to that, though here also the working is there, but a little more manageable. Now next we are coming to this. Again, that's, as I said before itself, that's quite complicated. So let's call this as y, and because sorry, you are in the exercise, you know you can do logarithmic, but this should click at the right time in the exam also, that this is falling into logarithmic differentiation and we have to do it that way. That is more important. So let's take the log on both sides. This is log y sorry, log of root x minus 1 into x minus 2 by x minus 3 x minus 4 raised to x minus 5. We all know that this is raised to half, and all exponents will come on the side of the log. We have log of a raised to m is m log a, means whatever exponent is there, that will come to the side and you will get the log of the remaining. So this will become actually half times log of the remaining. So what all are the remaining? X minus 1, x minus 2 by x minus 3, x minus 4, x minus 5. So there's a numerator denominator kind of thing. So this will become log of x minus 1 into x minus 2 minus, right? Because there is that numerator denominator. X minus 4 x minus 5. Now also this is a product here, this is a product here. So that also you can put it in addition terms. So this will become half times log x minus 1 plus log x minus 2. Now here these terms are getting added up because of that minus outside. This minus outside, it will go to each term. Like that each term will become minus. So it will become minus log of x minus 3 minus log of x minus 4 minus log of x minus 5. That's all. Right. So this is just log till now. Now we have to get the derivative. So now taking derivative, what we do is when we take the log, we will see that we will simplify everything, bring it to the most simplest form and then take the derivative, so that when we take the derivative, it will not look very clumsy. It is easier to handle. So let's take this. We are taking the derivatives on both sides. So you are getting d by dx of log y, and on this side you are getting d by dx of half times all this log x minus 1 plus log x minus 2 minus log x minus 3 minus log x minus 4 minus log x minus 5. Okay, so let's have this. So derivatives we'll take on both sides. See, one more thing that we should keep in mind is we all know that log x is 1 by x. As an extension, whenever we have a linear function in x, then that also will have the log as 1 by that thing. Like for example, suppose if you have log ax plus b. This is linear, isn't it? Because the power of x is 1. So actually what will be its logarithm's derivative is ax plus b, but because of this differential coefficient that a will come, and finally you will get the derivative as a by ax plus b. That much you keep in mind. Now here these are all x's, there is no coefficient to the x, so the derivative will be like for example log x plus a, the derivative will be simply 1 by x plus a. As simple as that, right? So you don't have to take separately chain rule and find it out. All that is not required. We'll keep in mind that we know that log x derivative is 1 by x. So log of a linear function also will have the derivative 1 upon that thing if it is monic. Monic means that x doesn't have a coefficient. It has a coefficient 1. Okay, so that's such cases. So certain things we do keep it in mind so that it can save our work. Like for example, this cos 3x we have learnt that is minus 3 sin 3x, so that we don't have to do the substitution for the 3x also. Okay, there's no harm in doing, but there's no need. We can always retain it in our mind, right? So that's how we are going to get across. Now we are taking the derivatives on both sides. As I said, like before, I will not be doing too much of elaborate steps. See, you know the half can come out of the derivative, and this derivative can apply to each term. So derivative of log, this we have learned there itself, it is 1 by y dy by dx. Half has come out overall, and we are going to take the derivative of each term. Derivative of log x minus 1, we have just now observed it is 1 by x minus 1. Derivative of this term is 1 by x minus 2. Derivative of this term is minus 1 by x minus 3, minus 1 by x minus 4, minus 1 by x minus 5. That's all. That's our answer, except for the fact that the y has to go on the other side. So the y goes there. So you will get y is what? Oh, root of, you can have half outside, root of x minus 1 into x minus 2 by x minus 3 into x minus 4 into x minus 5 times 1 by x minus 1 plus 1 by x minus 2 minus 1 by x minus 3 minus 1 by x minus 4 minus 1 by x minus 5. That's our final answer, right? That's about it. So that's how first taking the log and then understanding and then getting across doing the problem. That is how it is going to be. We'll go at a very slow pace over here because it's a totally new concept and we are doing two things at a time. We are doing log also and we are finding the derivative also. Log is otherwise this logarithm is supposed to be a chapter in the 9th standard in our earlier syllabus, but it has been deleted. So because of that we are totally new to this log concept, and so it takes time. Otherwise it would have been, had you learned it earlier, it would have been very easy and we could have done it in one shot, but because it's new to you, it will take time, and that is why we have to take our own time to build it. That's all about this. We are meeting with the more problems in the next video. Thank you.